Hello everyone, this is another video on numerical session on quantum mechanics. Where we discussed in the previous session we discussed about spin angular momentum. So here I'll be solving some questions from. I think this will be question number 36 in this series. Hamiltonian of a spin. Oh wait, I think I missed some. Oh sorry. Yeah, this is review 36. Find the trace of sigma x, sigma y, sigma x, sigma z, sigma y, sigma x. We have to find the trace. All right. Hmm. So how will you find it? See, it's simple. We will first do what sigma x, sigma y is how much we know. I sigma z, isn't it? Now, yeah. So first you do this. So this is your I sigma z, sigma x, sigma z, sigma y, sigma x. Now this two, sigma z, sigma x is how much? Sigma y, isn't it? Sigma y, sigma y, sigma x. Now these two, it's minus I sigma x because it's now, oh sorry, yeah, it's plus only, it's plus I sigma x, sigma y, sigma x, isn't it? Now, this is how much? This is your I sigma z, sigma x. This is your what? I sigma y. So this is your actual matrix. Okay, this is the final one, final power matrix from this calculation and trace of I sigma y. Okay, so trace of I sigma y will be what? Sigma y is your 0 minus I 0. Even if I multiply I sigma y, that is what? 0. This is what? 1 minus 1 0. So the trace is always 0. Trace of any Pauli matrix is 0. All the Pauli matrices they have trace 0. Sigma x trace 0 because 1 1 0 trace 0. Sigma z 1 0 0 minus 1. 1 minus 1 is 0, isn't it? So yeah, this is your this question. Okay, this can come as a 1 1 question in gate. Right. Next question. I left another question. Yeah, there is another question. 37. Find Sx, Sy, Sz, Sz, Sy, Sx, Sx, Sy, Sz, Sz, Sy, Sx. This is what we have to find. Okay, so Sx, Sy is how much? Sx, Sy we know is well. This is your I h cut by 2. I h cut Sz, isn't it? H cut Sz. Um, I h cut Sz, this is Sz. Alright, just a second. Okay, h cut Sz. So now Sz is how much? H cut square by 4, right? Sz, Sy, Sx. Now tell me, this becomes I h cube by 4. Sz, Sy is how much? I h cut minus Sx. Okay. Now this will multiply this will be h4 by 4. Sx square is how much? Square by 4. So this will become what? H. So about 6 by 16. Okay. So that will be the answer. Alright. Yeah. Next question. Question number 38. Find the eigenvalues of Pauli spin matrices. Eigenvalues of Pauli spin matrices we have studied is plus or minus 1. But if you want to confirm sigma x is equal to 1, 0, 1, 1, 0. So minus sigma lambda 1, 1 minus lambda is equal to 0. Lambda square minus 1 is equal to 0. Lambda is equal to plus or minus 1. Okay. Sigma y will be 0 minus I is 0. Okay. So again minus lambda minus I minus lambda is equal to 0. Okay. Lambda square minus so that is plus minus 1. That is 0. So lambda square is equal to 1. Okay, so lambda is equal to plus or minus 1, right? Lambda is equal to plus or minus 1. So the eigenvalues of Pauli spin matrices are plus or minus 1. Alright? Yeah. Next question will come. That's this one. Question number 39. Spin of particle is in a linear superposition of this one. So for example, the wave function is psi is equal to 0.8 up spin plus 0.6 down. Okay. So spin up, spin down state. If spin up, spin down are eigenstate of sigma z, okay, these are eigenstates of sigma z, then what is the expectation value? Exception with what? Expectation value, expectation. What is the expectation value to one decimal place of the operator 10 sigma z plus 5 sigma s? What is the expectation value? Right. So how will we calculate it? What is given spin up and spin down states are the eigenstates of sigma z. So sigma z eigenstates are what? For spin up, sigma z eigenstate for spin up is 1 0. For spin down, it is 0 1. Alright, so this becomes psi becomes 0.810 plus 0.601. Okay, so if we do this, this becomes 0.8 0.6. Okay, so now what? Yeah, this one, let's write this one. It's 10 sigma z plus 5 sigma x. Put the matrices. 10 sigma z is how much? Sigma z is 1 0 0 plus 5 into sigma x is 0 1 0 1 0. So this becomes 10 0 0 minus 10 0 5 5 0. This one 10 5 5 minus 10. Okay, 10 5 5 minus 10. So, what is given the expectation value of this one, isn't it? For example, this is your A. So, expectation value of this one is asked. How will we calculate? What is psi? Psi is your this one, isn't it? 0.8 0.0. So, expectation value will be what? Psi A psi. Right? Psi is a psi is your 0.8 0.6 10 5 5 minus 10 0.8 0.6. Now you just have to multiply this, isn't it? You have to multiply it. 0.8 into 10. So this is your 2 by 1 by 2 matrix. So 2 by 2 matrix. So the result will be 1 by 2 matrix. Okay. So what will be the result? 0.8 into 10 plus 0.6 into 5. That is 8 plus 3. That is 11. Okay. Now 0.8 into 5 is 4. 0.6 into minus 10 is minus 6. So 4 minus 6 is minus 2. Did you get it? Hmm? 0.8 or 0.6. So now again 11 into 0.8 is 8.8, minus 20 is minus 1.2. Alright. So if you this one will be, see, this is 1 is to 2, 2 is to 1. So the answer will be 1 is to 1. So 8.8 minus 1.2. That will be what? That will be what? That will be 7.6. So this is the answer. Got it? This is your answer. Answer is 7 by 6, 7.6. This is how you solve this type of questions. Alright? It's a very important question that come in NET, everything. Yeah. Question number 39 gone. Question number 40. It will be question number 40. Question number 40. The Hamiltonian of an electron in a constant magnetic field B is given by. Hamiltonian is given by H sigma dot omega mu by H cut. I is the 2 by 2 unit matrix. Okay. Then the operator e to the power IHT divided by H cut equals to how much? This is the operator. So we know, we have written a formula to the power what? We have written the formula, right? See here, I will just put here e to the power IT in place of H. What will I put? This is mu actually, okay? Mu. So what will I put? I will put mu del sigma dot B by H cut. Okay? Mu e to the power IT mu sigma dot B H cut. So if I expand it, it will be what? I cos, okay, omega t plus I sigma dot B sin omega t. Isn't it? Right? Isn't it right? Okay. How I did it? The I theta sigma dot n is equal to how much? I cos theta plus I sigma dot n cap sin theta, isn't it? Okay. So I did it this way. Hmm. Yeah, this is the answer. Okay. This is your answer. Next question, question number 41. See, psi1 and psi2 are two orthogonal states of spin half system. It is given by psi1 is equal to sorry, psi1 is equal to 1 by root 3 1 0 plus root over of 2 by 3. When the system is in a state site with probability to be in spin up state. Okay, system is in state psi 2, then the probability of it being in the spin up state. See, this is your psi 1, okay? So psi 2 will be how much can you tell me? Psi 2 will be, these are two orthonormal states. So Psi 2 will be root over 2 by 3, 1 0 plus 1 by root 3, 0 1, isn't it? Okay, alright. Yeah. So probability of psi 2 in the spin up. This is a spin up, spin down. So probability of psi 2 being in the spin up is how much? Right? P2 is root over 2 by 3 whole square. So the answer is what? 2 by 3. You may ask me how I wrote psi 2. See, psi 1 and psi 2 are orthonormal shapes. So this square into this square plus this, so like this into this plus this into this should be 1, isn't it? Because it's also an orthonormal shape. So it can only be root 2 over 2 by 3, it can only be 1 root over 1 by 3. Then only there will be orthonormal states, right? And after that, we just, what is the probability? We just write the P1 is equal to C1 square, coefficient of 1 square. P2 is equal to coefficient of C2 square. Okay. That way we can solve this question, right? This is, answer is 0.66 or 67. Next question, this is 41. Next question will be question number 42. Question number 42. Question number 42. A spin half particle is in the state I is equal to 1 by root 11 plus I by 3, sorry, 1 plus I 3 is in the eigenbasis of S square and Z. If we measure SZ, probability of getting, if we measure SZ, probability of getting plus h cut by 2 and minus h cut by 2. Probability of getting plus h cut by 2 minus h cut by 2. So chi is equal to 1 by root 11, 1 plus I by 1 plus I 3. So I can write chi as 1 plus I by root 11 up plus 3 by root 11 down. Can I write like that? Because your up is, we know, up is what? Up is your 1 0, down is a 0 1. So if I put it here, you will get this much only. Okay, right? Now, what is the question? If you measure SJ, probability of getting it, this is, so up has will give us a plus h cut by 2, down will give us what? Minus h cut by 2. Isn't that right? So, chi will be what? Okay, so probability of getting plus h squared by 2 will be how much? 1 plus I by root 11 whole square. Okay, right? That will be what? That will be 2 by 11. Isn't it? 2 by 11. Yeah. And probability of getting minus h squared by 2, that will be how much? Hmm. This is 9 by 11 because this is 3 by root 11, square is 9 by 11. Okay, these are the answers. 3 by 2 by 11 and 9 by 11. So now question number 42. So what I did here was, I was given, I just divided it into two terms like spin up because spin up will be giving me plus h cut by 2, spin down will giving me minus h cut by 2. Spin up we know is 1 0, spin down we know is 0 1. Right? So from there, after that probability we can write P1 is equal to C1 square, P2 is equal to C, like P1, like that means P h cut by plus h cut by 2 is the coefficient of up spin, that is this. P probability of minus h cut by 2 is square of coefficient of down spin, that is 3 by root 11, that is 9 by 11, right? And that is the answer. Question number 42. Question number 43. The Hamiltonian for a spin half particle at rest is given by. Alright. Hamiltonian of a spin half particle at rest is given by h is equal to E naught sigma z plus alpha sigma x. Okay. Sorry. H is equal to E naught Sigma z plus alpha sigma eigenvalue of this Hamiltonian. Okay, let's open this. This is 1 0 0 minus 1 plus alpha. Okay, E naught also. Alpha sigma 0 1 1 0. So E naught 1 alpha alpha minus 1. So E naught alpha E naught alpha E naught minus E naught. So the eigenvalues will be E naught minus lambda minus alpha E naught minus E naught minus lambda. Isn't that right? Yeah. Okay. There's the minus. So E naught minus alpha lambda. Sorry. So many things. I can write like this. Isn't isn't that right? Okay. I just simplified, kept simplifying. I did step by step, very slowly. Okay. This type of questions you do, like, take your time. You don't need to rush. For this, you will get 2 marks, so take your time. Don't rush and make a mistake. Instead, take your time and do it correct. That's my philosophy. Okay, then that will be it for this session. Okay, we'll do more numericals in the upcoming session.